Okay, for today's math experiment, we are going to measure the rate of marbles going down tracks to build a model that might be used on a road construction, on a ski slope, many different applications for this. So as you can see, I'm using the trash can as my height, my base. The foam is for the marble track. And then the little orange can is simply a support because it was starting to bow and I want to keep it as straight as possible. So the first thing I need to do is I need to measure the height of the trash can. So it looks to be about 37 centimeters. I'm going to use centimeters as my measurement here, and then of course as a scale we can make that into meters or whatever, kilometers if we're dealing with a really big ski slope. It all depends on what we're going to apply this to. So we also need to make sure that we are measuring the length of the track, and it needs to be from where the marble begins to where the marble hits the ground. We need to know the total distance traveled, and we're going to measure that, and of course look at how long it takes to move that distance so we can find our rate in centimeters and in seconds. So now I'm going to measure my angle, and I can do this from the ground or I can do this from my support. Some of you may not need a support, but I'm going to put the flat part of my protractor on the flat plane, which would either be the ground or the container, and then I'm going to follow the lines that are on the protractor and figure out what angle. And since I know it's going to be one of these, I'm not using these measurements, it's going to be acute. So I'm going to use the 30, the 40, the 20, whichever one it is. Looks like 30 degrees from here. And looking at following the slope, we're about 25 degrees from there. And if I were to try and follow a basic flat spot, I can see it's more like 30 degrees, and it comes into a 20 degree. So we're going to say this is going to be a 25 degree angle. Obviously, in a real model creation lab for a company I'm working for, I would have better tools than this and better materials. But you get the idea of what we're trying to make happen here. So now it's just a matter of taking my marble and rolling it down and timing how many seconds it takes to get from the trash can to the very bottom. So I'm going to start right at the base of the trash can, of the top of the hill, and I'm going to have one person hold it. I'm doing this by myself, but if I have partners, and then on the count of 3 we'll drop and go, and we'll do this several times and track it. 1, 2, 3. Took 0.61 seconds, so this is a pretty fast slope at this height. So our goal is to measure the height of the hill or slope. So that would be the trash can in my example. Might be books for you, a desk, a chair, probably lower. That was a pretty steep slope. The angle of the hill or the slope, that's using the protractor. Then the rate unit and the unit rate of how the marble is traveling. And then you want to do at least 5 to 10 test runs with your marble and timing it to find your average rate. And once you've come up with that, then we'll be able to use that and scale it with a real life model as construction workers of those different areas would do. And of course, we wanted to measure the length of the track so that we can find our rate unit and our unit rate, which would be the length of the track. The length traveled for every second is probably what we're going to be looking at there.